In this video, we're going to be talking about carb heat. An airplane needs three things to work: air, fuel, and spark. The carburetor provides the first two. Along with the carburetor, the airbox and the throttle form the aircraft's induction system. These work together to mix the fuel with the incoming air and deliver it to the engine through the manifold. The fuel is mixed with the air in the carburetor through a venturi. The venturi is nothing more than a tube with a constriction, and as a fluid is forced to go through this constriction, the pressure will decrease and velocity increases. Because of this decrease in pressure, fuel is drawn through the main discharge nozzle, atomizes, and mixes with the incoming air. The amount of fuel that is drawn through the venturi is controlled in the cockpit via the mixture knob. The amount of fuel-air mixture that is allowed into the manifold is controlled via the throttle. Carburetors are susceptible to icing due to the venturi effect, which states that as the velocity of the fluid increases, the pressure will decrease and there is a temperature drop. On top of that, there is a latent heat loss when the liquid fuel changes into a vapor. This drop in temperature, which can be as much as 30 degrees Fahrenheit, combined with moisture, can lead to the formation of ice inside the carburetor. This will show as a gradual decrease in engine RPM, lower EGTs, engine roughness and vibration, suck throttle, and eventually complete engine failure as the ice closes off the fuel-air mix, starving the engine. When is this icing most likely to occur? When the outside air temperature is between 20 degrees Fahrenheit and 70 degrees Fahrenheit with humid air. This is one reason to pay attention to the temperature dew point spread. Fortunately for us, we have carb heat. Carb heat is a very effective way to prevent and treat carburetor icing. Carb heat is controlled in the cockpit via a knob. When pulled, this engages a flap inside the airbox that blocks off the air coming through the air filter and scoop and opens a pathway that draws warmer air from around the exhaust manifold. This warmer air will raise the temperature inside the carburetor and melt the ice. One side effect of using this warmer air is a degradation in engine performance. Remember, this warmer air is less dense than the cooler air that was coming through the scoop, so the fuel-air mix will not be optimal. It is normal to see a slight decrease in engine RPM. Also, the melting ice will flow into the engine, causing roughness. It is important to keep that carb heat running even if the engine sounds rough. When should we use carb heat to prevent and treat carb icing? Carb icing can form under any condition, but it is most likely to occur at a low power setting such as descents or periods of slow flight. Check that the carb heat is working during every run-up by pulling the knob and noting a decrease in engine RPM. Here at upper limit, we use carb heat anytime we drop below 2,000 RPM in our fixed pitch aircraft, and when we drop below 15 inches of manifold pressure in our constant speed aircraft. Before increasing power again during a go-around, takeoff, level off from descent, or recovery from slow flight, make sure to push the carb heat knob back in to gain maximum performance. If flying through areas where you suspect carb icing may occur, occasionally cycle the carb heat for a few seconds, every 20 minutes or so, or as needed to prevent a potential issue. Check your aircraft's POH or AFM, or reach out to your mechanic if you have any specific questions about using carb heat in your aircraft.